Well, good morning. I got to apologize in advance. Dogs are going crazy. You're probably going to hear them bark at some point. So sorry about that. You should be open in module 6, which remember is halfway in the middle, in between your workbook. Lesson 4. And lesson 4 is creating a histogram. So you're going to learn how to transfer data today to a histogram. So first thing you should be seeing is this glorious example 1, frequency tables with histograms. Let me hide this. You don't want to watch that. Let's go with blue today, and then we can get rid of that. All right. So I will read this to you and kind of go through step by step. You're going to see me skip around a little bit because that's just what I do. So, frequency tables with intervals. The boys and girls basketball team at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell baseball caps with the logo on the front to family members and other interested fans. To obtain the correct cap size, which is another word for hat, students had to measure the head circumference, which is the distance around the head. So, in other words, they took a tape measure and they measured how big somebody's skull was. Of the adults who wanted to order a cap, the following data represents the head circumference in millimeters of the adults. So all of these numbers indicate how many millimeters every adult that they measured's head was. All right. So the caps come in 6 sizes: extra small, small, medium, large, large, extra large, and XXL. Each cap covers an interval of the head circumferences. The cap manufacturer gave students the table below that shows the interval of head circumferences for each cap size. The interval 510, that line is not a negative sign. It shows like the distance to something else. So it says 510 to less than 530 represents the head and head circumference from 510 millimeters to 530 millimeters, not including 530, because it's kind of like that less than, we're talking about like that less than or equal to type thing. Remember when we said, can it be this or is it going to be this? This says it's the head circumference is 510 millimeters all the way up to less than 530, which means it can't be 530, but it can be 529 and 9/10, 529.99999. It just can't be 530. Which makes sense because if you look at this next interval down, that includes the 530. The reason that we do this with our intervals, if somebody had a head circumference of exactly 530 millimeters, I can't count them in 2 places. I don't want to say, oh, well, they fell here, but 530 is also here. That means I'm counting them twice, and that doesn't work. So that's why we indicate with that less than sign. So what we have to do is take all of this data that we have here and organize it into our frequency table. So on the far left, you see all of the cap sizes. The next column indicates the intervals. Then we have our tallies. That's just where you indicate a little slash for each time you see a number in those intervals. Frequency is just how many tallies you have, is how often you see that number. So the best thing that you should do is go through individually and tally these off. So let's look at the first one, 513. I'm going to cross it off. That will fall here in between 510 and less than 530. So I'm going to put a tally there. 525. It's going to fall in the same one because it's less than 530. 531 will fall here because it's greater than 530. 533 here again. 535. 535. 542 still falls there. 543 still falls there. Here's what I want you to do. I want you to pause this video, finish taking each circumference and adding it to your tally column, and I want to see if yours is going to match mine. So I'm also going to pause. Okay, did you do it? Did you go through and check off each single circumference, document it with tallies? Then remember I said the frequency is how many you had. So I already went ahead and did this. I have 2 tally marks here. That indicates 2 there. 1, 2, 3, 4, 5, 6, 7, 8 tallies here. So that means it's a frequency of 8. I have 15 tallies here. So that's a frequency of 15. 9 here, 4 here, 2 here. So easy peasy on creating your frequency table. Now we need to answer the questions, but I'm going to leave this screen here. You're going to need to follow along in your workbook. So if you took a look at exercises 1 through 4, number 1 says, what cap size would someone with a head circumference of 570 millimeters need? So I need to look in my intervals and where would 570 fall? Well, I see a 570 here and I see a 570 here, but remember, you've got this indicator of less than. So for a medium, it says 550 to less than 570. So it can't be 570. It can be 569 and 9/10 there, but it can't be 570. So for number 1, if you had a head circumference of 570 millimeters, you would actually need a large. So you're going to want to write that for number 1. Number 2, it says complete the tally and frequency columns, but we've already done that. So we're going to skip number 2. Let's take a look at number 3. What head circumference would you use to describe the center of the data? The center really means the middle. It's kind of the middle of where you find everything. So the head circumference center would be somewhere around 550 to 570. This is somewhere in the middle. If I'm here, you've got a few intervals before and a few intervals afterwards. This corresponds to a cap size of a medium in this case. So number 2, you can put interval between, I'm sorry, that's number 3. I forgot. You already did number 2. Between 550 to less than 570. Something around there. Okay? All right. Number 4 says, describe some patterns you see. Well, what do you notice? Take a second if you'd like. What are some of the patterns you see in the frequency column? So what I notice is there's very few numbers at the extra small and the extra extra large, but most of the numbers are around the mediums. Oh boy, you hear Gunnar crying. Most fall in the medium. You can even say medium or large. Medium, large range. All right. So that is example number 1. I'm going to have you scroll down. So pause the video for a second to get yourself situated for the next activity. Okay, so example 2 is your histogram. What we're going to do now is take that data that we had from the frequency table and transfer it into a chart that we can read. So one student looked at the tally column and said it looked somewhat like a bar graph turned on its side, which it kind of does. If you look at your tallies, it's kind of like you did a bar graph, but you're just writing it horizontally. So a histogram is a graph that looks like a bar graph, except that the horizontal axis is a number line that's marked off in equal intervals. This is really important. So, in order to make a histogram, and you have all of this stuff, the first thing you'll do is draw a horizontal line and mark the intervals. So, here's the horizontal line. And I always start with 0, but I'm starting my intervals with what I have on my chart. So the first one is 510. The next interval started at 530, 550, 570, 590, 610, and 630. What you notice is that there is 20 in between each one. They have to be even like that. The next part is to draw a vertical line. Here it is. We're going to label it frequency. That's where you indicate how often those numbers happen. We mark the frequency axis with a scale that starts at 0, which we just did, and goes up to something larger that's on the scale. Okay. For each interval, we're going to draw a bar over that interval that has a height equal to the frequency for that interval. So the first 2 bars were already done. If you look at your table from the last example, it said 510 to less than 530. That was the extra small. There were 2 people. So we have this bar. It goes up to 2 and it gets shaded in. Then the next interval, this was small, 530 to less than 550, we had 8 people. So we drew a line up to 8, made a nice little bar, drew it over, and shaded it in. Our next interval was for medium, which went from 550 to less than 570. And this was our biggest interval. We had 15. So you're going to make this, fill it in. We're going to draw our line all the way up to 15, which is in between these two because we counted by 2s. And then you can shade this in if you like. I'm not really going to do a very good job shading it in. Okay. The next one is our large, which is an interval 570 to 590. And according to our chart, we had 9 of those. So I'm going to find the 9 here in between the 8 and 10. Draw my line in between. Do the same thing. Shade it in however you decide to shade it in. Our next interval was for our next size up, which was our extra large. We had 4 of those. So I've got 4. Shade it in. And my very last interval was my extra, extra large. We had 2 of those. So here's my bar. And shade that in. All right. So now that you should have all of those shaded, you want to try to make some distinguishing lines in between so you can see the difference. I want you to take a look at exercises 5 through 9. Now, if you scooted down to number 5, we've already done it. We filled in the rest of our intervals. Number 6 says, based on the histogram, describe the center of the head circumferences. The center of the circumferences is about 560. Now, what this means, the center, where's the center of your data? So I'm going to actually get a different color pen here. Let's go with purple. If I drew a line and I scooped it up and scooped it down, the middle is somewhere around here. That's where the center of my data is, which is I kind of went off to the side there, but it's just about 560. So question number 6, you're going to put 560 millimeters. That's the middle or the center of the data. Number 7, how would the histogram change if you added a head circumference of 551 millimeters and 569 millimeters to the data set? In other words, if we had a 551, it would be in here, right? And then if we had the 569, it would go right about here. If we did that, the bar for the 550 to 570 would go up to 17. So, number 7, it would go up to 17. Number 8, because the 40 head circumference values were given, you could have constructed a dot plot to display the circumference data. What information is lost when a histogram is used to represent a data distribution instead of a dot plot? Okay, well, number 8, in a dot plot, you can see individual values. In a histogram, you only see the number of values in an interval. I'm not actually going to have you write that down. That's just something good to talk about. And number 9, we're actually going to skip for right now. All right, so I want you to pause. Make sure you have your frequency table in your histogram completed. Make sure number 6 and number 7 are written in. And then after you check that over, you can continue. All right, so I'm skipping a lot. I need you to go to exercise 10 through 12. Oh, there they go. Oh, there they go. Okay, the dogs are calmed down. I had to pause my recording because they went crazy. Anyway, you should be on exercise 10 through 12 now. So we did a little bit of skipping. Some of this you're going to do on your own, and I am going to check it, but a little bit we're going to do together. So, number 10. The histogram below shows the highway miles per gallon of different compact cars. All right, let's analyze this. So this is a histogram of highway mileage. The bottom or the horizontal line indicates the highway mileage or miles per gallon. So how many miles you can drive per gallon of gas. And this is the frequency. So this is how often or how many cars that happened to on the ones that they looked at. So this interval is cars that got 28 miles to the gallon to less than 31. This interval is 31 miles to the gallon to less than 34, 34 to less than 37, 37 to less than 40, 40 to less than 43, and so on. And this is how often that happens. So if I had the question, well, how many cars got 34 to less than 37 miles to the gallon? I can look, and it looks like there were 5 cars that fell in there. Okay, so let's look at part A. The first thing says describe the shape of the histogram. So the shape, what you do, you're going to draw a curve on the outside of this data, kind of like how we found the center of the other data. So take your pen, and I want you to draw up around the top, and then you'll notice it comes down here like that. That is not a perfect bell shape. So that's actually really telling of some of the data, because the next question says describe the shape of the histogram. Well, in this case, it's skewed right towards the larger values. In other words, it kind of gets a little wonky to the right side over here because you've got this random one car that got that many miles to the gallon. So for part A, we're going to say it's skewed right. Okay. Make sure you write that down. I'm going to clear that. The next one, it says draw a vertical line on the histogram to show where the typical number of miles per gallon would be and a compact car. So typical is about the average where you see the most happening. And if you take a look, here's your vertical line. This is about where most of it's happening, is right around here. So I would say that's about 36. So for part B, you would say about 36 miles per gallon. And part C, what does the shape of the histogram tell you about the miles per gallon for compact cars? Well, remember that shape was kind of what we did here. It says most cars get around 31 to 40. If we notice from this area to here, this is where most of the cars are falling. So most cars get about that. But there was one car that got a whole lot more. So for part C, you're going to write most cars got 31 to 40 mpg, miles per gallon. We're going to skip number 11. You're welcome. I'm going to clear this, so make sure you have it. If you don't have it, pause, go back, do what you need to do. Okay, now you notice I have a blank screen, which means we're skipping the rest. You're welcome. However, that doesn't mean you're off the hook. You've got 2 things you need to do. You need to come and get a mastery check, which is an exit ticket, to see if you can answer the here, Gunner, to see if you can answer the questions about data that you're given. Then your next task after that, should you have time, which hopefully you do have time, you're going to work on the problem set. Now, your ed puzzle that you're working on right now, you need to make sure you have a 75 or better. So if you don't, that's not good. You want to make sure you go back and fix that so you have 75 or better. I'm sidetracked because Gunner keeps crying. So sorry. Anyway, then finish the problem set. I will be checking this when I come and I see you tomorrow. Have a great day. I'm sorry I was not there. I hope you guys were good. I know you were, because you wouldn't make me sad, right? Okay, bye.